Greetings, and here we go with another MIT Integration B problem. This problem, I believe, is 2006 number 7. This actually is a fairly straightforward problem. It's a nice problem. It's a good problem to do, but it's fairly straightforward because you don't have many options of how to attack it. So, the only thing you can really do is what's going to end up working. So it's probably not a problem you would miss, but it's still a nice problem to do. So this one's going to be rather quick. So let's go ahead and get right into it.
Specialized in science and mathing, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe-to-toe, impeccable, splitting your back, son, simple as addition and subtraction, black thought, the infinite relax one.
All right, so we have the integral, and we have a definite integral of sine square root of x from 0 to pi squared over 4. So the reason I was saying this is, the only thing you could think of to do, if to do anything, is to do a u substitution and to make u equal the square root of x. There's really not anything else you can do. I guess you can use some type of trig identity, but by far the most obvious thing to do is to make u the square root of x, and that tends to be the guy that gets the job done here. So let's go ahead and continue the process. And so du would be 1 over 2 times the square root of x, which means 2 times du would be 1 over the square root of x and dx. 1 over the square root of x dx. And the square root of x is actually u. So 2 du is 1 over u dx, which means that 2u du equals dx. All right, so this dx is going to turn into 2u du, and you'll have the sine of u. So I'm going to go ahead and change the variables as I do the substitution. So when x is 0, u is 0. And when x is pi squared over 4, u is pi over 2. All right, so there's the change of variables there. And then our dx is 2u du. So 2u, and then this will be sine u du. All right, so that's pretty much it. I mean, it's not like it's very simple from here, but this is integration by parts. It's fairly basic integration by parts, but maybe this could cause some people to ponder a little bit, but this is fairly straightforward integration by parts. So let's say w is u. So that means dw is du. And let's say dv equals sine u du, which means v would be negative cosine u. All right, and so if you just think about integration by parts, so if I'm integrating, say, w dv, that's going to be w times v minus the integral of v dw. So w is u, so this is u. V is cosine u, so minus u cosine u minus the integral of v du, v dw. V is negative cosine, so plus cosine u, and dw is du. And all of this is being multiplied by 2. So this guy is being multiplied by 2. And so the integral of cosine u is sine u. So this is 2 times negative u cosine u plus sine u. And I almost forgot this is the definite integral. So this is a definite integral. So let me evaluate this from 0 to pi over 2. All right. So I almost forgot about the definite integral part in real time there. So let's go ahead and plug in pi over 2 and plug in 0 and see what becomes of this matter. So 2 times. So if I plug in pi over 2 for you, this will be negative pi over 2 times the cosine of pi over 2. The cosine of pi over 2 is 0, so that would be 0. Plus the sine of pi over 2. The sine of pi over 2 is 1. Minus, if I plug in 0, it'll be 0 times cosine 0. So that's just going to be 0, and it's going to be plus sine 0, which is just 0. So it's 2 times 1, or 2. So that one was rather quick, rather straightforward. Still, it still involved, a little bit U substitution with the addition of integration by parts. So it was a pretty good problem. We'll see you next time.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.